for it to discharge. Now take your red lead and put it to the one next door. That'll be your VCC. You see that one doesn't discharge. That one stays there. Okay. So we're happy with that. The other ones you won't test because there's no speed. Because your fan's not running, there's no point to check it. But let's say if you feel like there could be a problem with fan when it operates, that's a good time to check it. Because let's say you get full fan speed and you've noticed that the fan speed doesn't change. That's when we'll show you now while we run it. Then we'll check the VSP and see if that voltage actually changes. Because it should start off low, approximately 2 VDC, and then it will work its way up according to what the indoor is doing, because this changes the head pressure. So when this fan speed, it obviously changes the head pressure. When it's the other way around, obviously we don't have a unit to change head pressure. That's because we have an EEV and we can control the compressor. But in cooling operation, the fan speed will decrease and speed up according to what this head pressure is. I don't know where that other gentleman is. So you've checked that now, we're happy with that. At this point you found no problem. And I can tell you quite honestly, if you've tested your fan, you've got your voltage, you're already going to know that you've got your DS2 voltage, which is here. You know you've got that voltage. We haven't got on the control circuit yet because we haven't checked that yet. What you could do now is check between your number 2 and 3. So check on the same DC voltage and check between 2 and 3. And let's see what that does. See, it's fluctuating. Even though your indoor doesn't run, it will fluctuate because it's busy communicating with that indoor. Now, if we were to let's just do this, and let's pull off number 3. Okay. And actually, I should have pulled that one off. Could you just give me a screwdriver and disconnect this number 3 for us? We'll get away with it. Easy. Just disconnect number 3 and that there. Okay. Now we're going to power on and we're going to check between 2 and 3. Remember we were fluctuating before? Now we've got no indoor unit communicating. 23.2. So remember we said we're looking for 20, but you can have 2 or 3 volts up or down. So I'll just explain what we've done here. Is we turn on the units, we look for our 340. We got our 340 and we notice it discharge. Remember we saw it discharging? We check VCC, that one doesn't discharge, it stays there. We then went to 2 and 3, we want to look, because now we want to look at the switching circuit to see if it works, so we're looking for our 20 volts. We saw fluctuating with the 3 plugged in. We disconnected the 3, Gary checked again, we got 23 volts. As mentioned before, we can have 2 or 3 volts different to what we're actually looking for. So we're quite happy with that. So we'll turn that off again. Can you plug that one back in for us? So what I normally do is also look at what the fault relates to. We don't have the service board handbook in front of us now. Why is this thing not working? Am I using the wrong port?
351.
Yeah. Well, that's why it wouldn't work. Okay. So the reason I'm saying that before we test is if your error code is related to sensors, normally all the run where the run light is flashing, timer is on constant. Most of those are going to be related to sensors. If it's sensors, you want to make sure the board is outputting the correct voltage to the sensors. So we want to make sure the 5 volts is there. So if we look over here and we look for our 4 to 6, there it is there. And where's this pointing to us? Pointing to that there. So we can check across those 2 points. Will it be on? Sorry, Gary. Okay, now remember there is a protective layer. It doesn't always make great contact. So just There we go.
Yep. 5 volts.
So now we also know if we've got our 5 volts, we know we're going to have our 30 and we know we're going to have our 20. There's no reason to even be checking it. So what we've just done now is we've literally almost completed literally all the tests we need to do. And that will literally cover almost every fault that you have. Not the indoor, obviously, we haven't tested the indoor, but I'm talking on the outdoor side. What can happen sometimes, and I'm not going to go into too much detail, but I'll just touch on it now. We have a service tool called it's DMCT, where we check in the fan output, if the fan works. And we also have inverter checker. So inverter checker plugs into a CND ROM port, which is situated, I can only see it when I look from this side. Yeah, it sits there. Yeah, that's exactly it there. And if you look here, you'll notice it always sits behind the fan plug, and it's actually a missing plug. So our service tool actually plugs into that, and it bridges the points 2 and 3 together. So what happens is with power off, plug in, with those 2 points bridged, power on, the unit automatically puts itself into inverter check mode. Before we do that, however, we would have taken the screws off and disconnected the compressor. This would be a good way to check if it's compressor or is it actually board. Because you might have replaced this board and it didn't run. So you want to figure out, is this board actually right or doing what it should? You have your high DC voltage, but you don't know if it's outputting UVW voltage. So if the compressor is faulty, with that UVW plugged in, it will automatically error. You won't have enough time to test it. So what we do is we put the unit into inverter check mode. We could also be bridging with a screwdriver if we had one. We might not do it now, but I'll just show you. Well, mind you, we don't have UVW unplugged, but what I would do is just switch off there for a second. So on that CND ROM, if you don't have the plug, you look for points number 1. It'll always be to the left. There's 1 over there. You can see it above that point. So there's 2 and 3 there. So what you would do is take your screwdriver, wedge it in there. What I normally do is just hold it against the plastic, so you know that's not going to move. Because if you were doing like this, obviously you can move it. If you hold it like that and it's not moving, you can normally, if you're by yourself, you can switch it on, and then you can grab your multimeter and you can position it so that you can check between U, V, W. Obviously U to V, V to W, etc. And you'll get your high voltage AC output to your compressor. And that'll be another hand. Well, I'm showing you that you can actually do it on your own. It's not very easy. If you have the plug, it makes it a bit easier, and I'll show you where you can get that plug. If you ever remove one of these indoor units and you're going to abolish it, or we're going to pick it up from you, to abolish it, you're welcome to go and strip out that indoor on the assembly for the remote control. There's a little board. They call it a display assembly. That's what it is. And there'll be a little white plug in there. It's the same size plug that fits into CND ROM. And what you can do is just add a little wire loop between 2 and 3 and keep that as part of your toolkit. So if you ever want to check inverter mode, power off, unplug UVW, plug in the CND ROM, turn on power, and then just check between UVW. U to V, V to W, W back to U. If you get your high AC output, as long as they're even, so it's similar to windings, they'll normally start off between 220 to 100. Let's say it starts off at 85. So if you measure U to V 85, V to W you want to measure 85 again, and W back to U and measure 85 again. If one of them you read it a bit higher, double check the other 2 because it might have stepped up to the next higher voltage. And just check it again. If you get even voltage outputs, I can tell you that board is 100% fine. Because it will not output UVW voltage if there's something wrong on that board. Something would have stopped it before it got there. But anyway, the testing that we've done in most events will be 99% conclusive that we've done. So before adding this, just to repeat what we've done here, power off, unplug your components. While the unit's busy resetting, you can check the resistance of your components. You can plug in all your other components. If you're not sure if your fan is good, or if your fan is good and you're not sure if the board is faulty and it might take out the fan, leave your fan unplugged. and then power on and check it for your voltages again. Because it won't go into fault until you switch that unit on, like if there's no voltage over there to that fan. When you switch it on, it's looking for the feedback through VFG. It picks up, okay, there's something wrong with the fan motor, it'll go to E48, it'll run on time 7, for instance. So just to back step again, you've plugged it in, you've switched it on, you'll start off between VM to ground. You'll look for your high DC, which is your DST2 voltage on your fan plug. Next, look for your control circuit voltage. Then you've confirmed both diodes, because one is DS2, high voltage, 14 volts comes from DS1. You've confirmed those voltages are there, then you know in most cases that board will be good. The next point is then to go and check 2 and 3. If it's fluctuating 4 to 60, you know that board is communicating with that unit. If you see there's only 20 volts, you already know that there's no communication. You know that that board is outputting 20 volts to the indoor, but it's not receiving feedback. So as Damon mentioned, leave your 3 plugged in, go to the indoor, obviously with power isolated, disconnect your 3 off of your indoor, and check between 2 on the interconnecting block and number 3 wire by itself, and look again for that 20 volts. If you find no 20 volts, but you had 20 volts here, you know it's your interconnect cable. That needs to be replaced. So you can run a dummy read to confirm that it is that. If you've confirmed it, then you can go to the end user, say, look, I've confirmed it. You need to run a new cable. This is your extra cost because now it's non warranty. You need to discuss that with them. Obviously, if it's warranty, obviously if it's non-warranty, it's a different story. But if it's warranty, discuss it with us. We can discuss with them, or you can just discuss directly. So you've got your fluctuating voltage. You've got your high DC on your VM winding. You've got your 14 volts on your switching circuit. The only other one that you didn't really check above your 13 would be your 20 volts, but you've just checked it on your interconnect. So in fact, you've now confirmed that all of these voltages have been checked even before you've put that board on. So this is just to simplify for those that don't understand this. If you do get stuck, get tripped up, get one of these, because you can just pop that on there and you can just go through the test like that. If you do want to know, obviously if you're a warranty service agent, sometimes we want to know on a resistance check what failed that board. In most cases, I'm talking 90% of the case, it's going to be these RGBTs. So we would go E2C on a diode check, which you can possibly do now quick because they're busy. So is that off? Yes. You'll go E to C, C to E, and then you'll confirm if that diode's good or not. Just check this here. So diode function, everyone's familiar with diode function?
Yep.
Okay, does someone want to test for us? E to C on that diode. Just on the IGBT. 0.46, which is perfect. And now go backwards, C to E. It's one they don't put there, but I always check it because that's the one that fails. So you see it's OL. So normally when they fail, you'll get a reading both ways, or it'll be OL both ways.
0.6.
Yeah, I mean they do list the other tests, but but in most cases you will just be checking E to C, C to E. If you're not sure, then just follow this and obviously suffice. Because now on your warranty service report you can go right there, RGBT, E to C, failed test equals 0 volts. We don't on warranty look for all the testing being done. We only look for the one test that failed that component. That's the only test we want. So that would be what you'd be writing on your report. C to E failed as was meant to be OL, but is now got a value to it. So that would be the main one that you would double check. Obviously, as Damon mentioned, varistas. If you were to check that now, you would find that it is you would be getting OL, which is good. If you get a reading there, it means that it's made a pathway. So they obviously say